Hey folks, welcome back to the shop. Frank here. I've got another little interesting project at hand. So I mentioned several months ago, if you follow my channel, I mentioned a couple months ago that I went to an estate sale and picked up some tools, a toolbox, a TIG welder, the hydraulic press. I think there was a video on that a couple weeks ago. And one thing I didn't mention that I picked up was a lot of older gasoline engines. And so today, this episode, I want to play with one of these engines. It is a Maytag engine, and this one looks like it's in pretty good shape. Got another engine over here covered up. That's a secret for another episode. But this engine is Maytag, and I believe it is a model 92. I don't know when it last ran. I think it's been in storage for some period of time. I don't know how much you guys know. I'm sure some of you guys are familiar with these engines. It's a hit or miss engine from probably the 1930s, 20s or 30s. This one may have been restored. I mean, it looks pretty nice for being, you know, almost 100 years old. 88, at least 80, 85 years old. So it's in pretty nice shape for its age. Now these engines, and I don't know a whole lot about them, I'm just beginning to learn about them. They have a flywheel here. The flywheel has vanes in it, so it acts as a cooling fan as well. So it rotates clockwise, so it blows air across the cylinder head. And it's a two-stroke engine. Fuel tank is below, draws fuel up, air in, and it's a two-stroke engine. As I understand, the oil to gas ratio on these is 16:1, so it's kind of rich in terms of oil. It is a kickstart. Push down on this pedal to start it. And these engines, I think they were used in the old Maytag washing machines, and that's what you usually see them associated with. The washing machines, I don't know if they were ringers that also used them. If you have experience with these type of engines, put in the comments what your experience is. I haven't done anything with this. It's been, I mean, I've had it for about 6 months. Have not really done anything. It's the first time I've put it up on the table. And I'm gonna clean it up a little bit, see what's in the, we'll see what's in the fuel tank. We'll pull the plug. The plug is pretty rusted. Try to get a new plug. And we'll check for spark, and hopefully we'll get it running. I've never had a hit or miss engine before, so I'm not particularly familiar with them. This one does have a pulley on it, so maybe we'll find something to hook it up to if we can get it running. Got to stop here to ground the plug out. So I don't know. It's interesting to think that, and I can certainly understand it in the 20s and 30s, as the country was just starting to be electrified, and before the rural electrification program, you know, made it out to all the farms and rural communities, washing machines were a great labor saver, and you can see why people would buy a washing machine and run it with a little gas engine if if that was the only way they had to do it. So it's kind of a cool little engine. Pretty simple since it's a two-stroke. I mean, there's no valve train. It feels like it has compression, so we'll take it slowly here. I don't plan on a complete disassembly unless I can't get it running. But it looks like it's been, I'm going to say, it's been restored. It's in beautiful condition. If it were original, it would be, I think, phenomenal condition. Given that the tag on here, I don't know. I mean, it's at a reproduction tag or an original tag. I don't know. It looks too nice to be original condition. So I'm going to say someone's restored it, and we'll get to play with it. So stick around. Let's see if we can get it running. So I don't know a whole lot about these Maytag motors, but I'll tell you what I think I know. All right, so this is a Model 92, as I understand it, and it's actually, they came in several frame sizes, and this is a long frame. It's a fuel tank under here, draws fuel up through the carburetor here. There's a fuel mix control here. This is and the magneto points behind this cover. I understand they made well over 1 million of these engines. It is, I believe, what you would call a hit or miss engine. Runs about 1,000 RPM. I think it's fractional horsepower. All right, so it looks like the points are here. Coil here. Magnets on the inside of the flywheel. See if we can get a better view here. All right, so the points are here. There's a coil. And there's, you can see a magnet there on the inside of the flywheel. So this looks like a reproduction, a new piece that someone made to fit over this opening. There are parts available for these. I mean, there were so many made. There's still a lot of them around. There are collectors of these. I think it's a little bit interesting that the spark plugs are actually 1/2 inch pipe thread. Alright. I'm going to see if we can get a spark here. Don't see a spark. I'll bring you around here. Get zoomed in a little bit maybe. Alright, don't see a spark. Let's look at the points. Alright, you can see the points opening right there. Pretty big gap on the points, just looking at it. Alright, we'll take a little piece of sandpaper and clean the points. Just got a little piece of 320 grit. Somebody's worked on this. They've got a modern capacitor in here. Got a little get a better flashlight. There we go. So you can see they've got a modern capacitor in there. I mean, everything else in there looks clean. I would think this would considering its condition and the fact that it's, you know, mounted on this skid or set of 2x2s, it's clearly been worked on, restored. So I think it should spark. But I don't see a spark. Let's try a new plug. No spark. So I'm getting a little bit of oil, pressing down on this ball, detent, getting a little bit of oil on the, I believe these have sleeve bearings. All right, no spark. Let's see what we need to do here. It wasn't even tight. It wasn't very tight. Looks like it's keyed. So I think this is the governor. Okay. That comes off pretty easily. So it looks like this got dinged there. Definitely got a hit. It wasn't me. So this looks like the governor. I'm going to say is a governor. A little weight, it's adjustable. This screw, the amount of spring tension. These are magnetic here and here, though this ring doesn't feel. Feels like a magnet there. Well, look who's here. My butchie boy. How you doing, huh? It's cold outside. It's still cold outside, middle of March, and it was 35 degrees this morning. You being a good boy? Huh? You being a good boy? Yeah. I know you are. I know you are. Alright, so we can see the coil, points. So I'm going to guess that this pin comes around, opens the points by hitting here. This pin hits that arm and opens the points until adequate RPMs are achieved and that pin moves inward and no longer hits the points. Hits this arm to open the points. And of course the spark occurs when the points open and the circuit is broken. It causes the field to collapse in the coil, which creates a spark. So I will do some more troubleshooting here. We'll check the condenser or capacitor. That's not the standard capacitor that would have come on these machines or these engines, but we'll check that. The other thing we can do is we can check continuity of the coil. So let's get a meter and do some checks here. Flywheel off. Let's check the coil for continuity. From what I understand with these old engines, the primary seldom goes bad, but the secondary sometimes does. So I'm going to get the points open here, rotate the crank enough to get the points open. Take the plug, loosen the plug up. Alright, so in order to do this I want to open the points, so I'm going to put a piece of paper between the points. Okay. Now test the secondary. Go from the ground to the end of the plug wire and See if we get the meter here in a position where you can actually read it. Yep, no, that ain't going to work either. Let's try it like this. Okay. So from ground to the end, we should see some like 4, 5, 6 ohms. I'm getting megohms, 3 megohms, basically open circuit. So that looks like I mean that range there is megohms. So it looks like an open circuit. So I don't know whether this coil has failed, potentially has failed. Let's take this apart here. This is where the plug wire plugs into the coil, and we may just have a bad connection here. Or it may be a faulty wire. From what I understand, these wires need to be, a copper core wire, traditional copper core, not a resistance wire. This looks like it's actually been soldered to this, so that would make it a copper wire. So maybe we're okay there. Get these couple little screws off. All right. All right, there. Move this. Okay, so there's the connection. Let's check the wire for continuity here. And let me see if I can get a good connection here. I'm going to have a bad wire because I'm seeing going from open circuit to a couple megohms. Well, there I got a couple ohms. Seems to be a lot of noise. There's 1 ohm. It's not so easy to get a good connection here. Getting All right, it says it's cycling around 2 megohms. So I'm moving this connection around and I get down to a couple ohms. I think it may be a bad connection in this wire, or a bad wire, because it's cycling between basically open circuit and 1 or 2 ohms, depending on how I twist the wire as I'm testing it. Well, there it's 0.2 ohms. So I don't know if you can see, there's a solder joint here. If I touch that solder joint, I have continuity. If I'm touching up here, I don't. So I think we can fix this. Clean this up, resolder it. It's supposed to have a this is a solder joint on here. It's supposed to be a solder joint, but it's not a good one. If I touch the probe to the end of the solder joint, I get continuity through the cable. If I touch it up here, I don't. So there's not a good connection between the wire coming out of here and this clip. It's supposed to have this punch here is supposed to create a point which is supposed to go into the wire and pierce the conductor on the inside and create contact, but I have a feeling this is a bad connection. Let's redo this connection and see about improving this. Alright, so I just want to check and see how much wire I've got. If I can cut it off and I think I have enough extra cable here to cut it here, take this connector off, clean it up, reconnect it. So let's do that. So we'll check the coil again. I get 6,000 ohms. Which seems high. Yeah, I don't know. That 6,000 ohms seems high. My understanding is it's supposed to be about 6 ohms. But maybe I misunderstood what I was told. But we definitely have a problem with this cable. So let's go fix the end of the cable. What do we have here? My little Brutus. What you doing, huh? What you doing? You being a good boy, huh? You being Daddy's good boy? Yeah. Okay. Yeah. You're my good boy. My good boy. I'm going to try to melt this solder. try to pull the wire out of this clip. There we go. I'll let that cool for a second. Cut a little bit off the end of this and redo it. He's got a hole here. Clean this up so that we have a nice clean area to solder to. We'll try that. Let's see if we can clean this up. All right, looks like we got a nice clean surface there. All right, I'm going to clean this up a little bit too. Okay, so I see that the spike that's supposed to be, this piece punched in is missing, so there's no connection to the core. The only connection will be what we make here. Wires are a little bit corroded. Okay. Let's see if we can resolder this and get a better connection. I mean, the key to soldering is you have to get both components heated to the temperature to melt the solder. So it's 600 or 700 degrees. And then, of course, you don't want to move it while it's molten. And the larger the piece of metal you're soldering, and this is a rather large piece of metal, the longer it's going to take to cool. So you want to give it plenty of time to cool before you touch it. Otherwise, you create microfractures in the joint. And so it's called a cold joint, and it's going to have poor conductivity and perhaps poor longevity, so it's something you want to avoid. I mean, the sign of a good solder joint is a nice shiny, reflective surface. So I think that's fine. It's cooled. Let's make sure we got a good connection there. All right, so that wire's soldered to that leg. I didn't solder it down here because it's much harder to heat this large mass of metal than it is to heat one of these little fingers. So to get it up to the proper temperature, to get a good solder connection, that's what I chose to do. Alright, so let's check the continuity through the cable. Alright, so go back to ohms on the meter. And we'll go from one end, I'm holding it against this clip, and the fingers on the other end, and I'm getting basically, less than an ohm resistance. Okay, so that's good. Let's put this back in and check again and see if we have spark. All right, let's see if we can get a spark here. I'm going to hold the plug against the magneto plate. I'm not seeing any spark. I think our coil is bad. Come here. You being my good boy? Look at my good Butchie. And my good Brutus. Yeah. It's cold outside this morning. Frost on the ground. Yeah. Yeah, you my good boys. All right, let's get back working on this motor. So as I've said, I'm not an expert on these motors. Done a little bit of research, but I'm getting a little bit confused, and I don't know if any of you guys know more. Put a note down in the comments. What I've been able to determine, I think, and I have solved the problem. I'll show you what I did. So, based on my research, the coil, the secondary, that is the spark side of the coil, is supposed to be about 6 ohms. You know, from 4 to 8 ohms, something like that. So from the inside the tower where the connection is to these laminations, which are grounded to the magneto plate, is supposed to be 6 ohms. I get 6,000 ohms when I test it, and I've used two different meters. I get the same reading, a little over 6,000 ohms, 6K ohms. So I don't know whether the people that published that information didn't realize they were measuring 6K ohms and they said 6 ohms, or what. So I don't know. But I did manage to, I came back out here last night frustrated at not being able to get this to get a spark, and actually thought that I was going to need a new coil. What I wound up doing is putting a new capacitor, a new condenser on here. I went to my stash of Cub Cadet tractor parts and pulled another condenser, fastened on here, put it back together, and darn if I didn't get spark. So let me put this back together here and I'll show you. These are pretty simple engines. This is a 2-stroke engine, so it needs an oil and fuel mix. So we'll have to do that next. When we get ready to fire it up, we'll mix up some fuel. Just put a little bit on there. I'll bring you in here. We'll look at the plug. Let's see if I can get you. The other thing I did was reduce the gap on the plug, and I'm going to say it's about 15 thousandths right now, which is less than you would normally have for a spark plug. Alright, so let's see if we can get a visual here on the spark. So we'll look right here. If you can see that on the camera. All right, I think you could see that. Pardon my shaky hold. Okay, so I've got spark, so I'm going to put this back together and turn our attention to the carburetor and the fuel tank, since I did put some oil. I don't know if you saw me put some oil in there, I don't remember. Been working on this now for 3 or 4 days on and off between my other chores. It's March 21. I spent all day yesterday doing yard work, basically getting ready for the spring planting, mulching, and that kind of stuff. So I haven't done a lot with this over the past day. Fortunately, there's a lot of resources online for these engines. I ordered some stuff from a company called Flywheel Supply Company, and they have so you can buy parts, gasket sets, and that sort of thing. I did when I first bought these engines, and I'll spoiler alert, I bought 3. Well, I bought a lot of 11 engines, and I got 3 Maytag engines in the lot. One's in parts upstairs in the storage. Okay, so that's on there. All right, so it's time to look at the carburetor. Let's pull the carburetor off. It's right here. And then we'll take a peek in the fuel tank. I'm going to guess we're going to have to clean the fuel tank out. Probably be a good idea to do that. So let's reposition the camera and let's work on the carburetor. I also bring out the monster screwdriver here. These look like brass screws, and they're not too tight. They're coming out pretty easily. Switch to this smaller one, they're loose. So my plan here with this, and I don't know if I mentioned it, is not to disassemble or do any kind of a major complete restoration on this. I mean, it's in pretty good shape. My plan is to clean it up and get it running, and decide what I'm going to do with it. It does have a pulley over here for driving something, so I may think about that. There are only, I think, a half or 3/4 of a horsepower. Okay, so there's the carburetor. It's got a gasket here. That looks like that's in decent shape, so I'm going to set that aside. Hopefully be able to save that. And looks like there's a gasket on here as well. This is the intake for the fuel air mixture. Comes out of here. So this is the fuel intake. This is the mixture control, air intake here, and this is a vent for the tank. Alright, so I'm not going to take this apart. I'm going to see, before I take this apart, because this is in good shape, I'm going to assume that that at some point somebody went through and worked on this. So rather than disassemble it and start messing with it right away, I think it's would be fine to just go ahead and see about running it the way it is. Alright, so this does give us a view into the fuel tank. And it looks clean. So I don't see any sediment. I mean, it's a little pitted. A few little rust spots. But I don't see any junk in there. All right, I'm going to say we could put fuel in there. Let's put this back together. So we're going to just see if we can get it to run as it is without any major work, since it looks pretty clean. I know this screwdriver is too small for these screws. I'm not going to tighten them in. I'm just get them in there. I'll come back with the proper screwdriver. Snug them up. I'm going to assume this is the fuel fill. That's loose. Alright, I'm going to get some fuel, and oil, and we'll mix some fuel and oil up. So these engines were made, this is, I think I said 1928. As I understand it, Maytag got the first engine in the early 20s. It was called an upright. It was similar to this, only the piston was vertical. And they got that engine from Elgin, and purchased the rights to manufacture engines like that. I've read that at some point, maybe Elgin made engines for Maytag, but then other people dispute that. So it's not really clear, but in any case, Maytag marketed several versions of this engine to run their washing machines, and the model numbers on these engines are actually the model numbers, the numbers that are used to refer to these engines today. This is a 92, was actually the model number of the washing machine. So I think the upright was, maybe that was an 82. Anyway, there were various model numbers, and they were really the washing machine model numbers, not the engine model. These were just called multi-motors. And so, okay, I'll come back. We'll come back. I'll get some fuel and some two-stroke oil. We'll make up a mix, put some in the tank, and see if we can get this thing to fire. All right, I mixed up some fuel here. This is 16:1, and it's two-stroke outboard motor oil, mercury quicksilver. I think it's TC2 or TC4 rated. Anyway, it's good outboard two-stroke oil, mixed 16:1. So a gallon of ethanol-free gasoline to 8 ounces of oil. I got my little Coleman lantern fill funnel here. And let me just make sure. Yeah, okay, there's a drain plug on there, but it looks like it's okay. Put a little in here and wait a second to make sure it's not leaking anywhere. Okay, we've got some fuel in there. I don't know if I have enough to reach the pickup for the car, but I think I do. So I've got this in the open position, which I'm going to assume is the needle valve open to allow fuel to go through. Oh. Well, that worked pretty easily. All right. I've got, it's definitely got some smoke. We may go outside to do this again. Of course, I put a lot of oil in the cylinder, so that may be part of the reason it's smoking so much. I've got a muffler to put on here, so let me go get that. All right, I got some gaskets here. I've got a muffler with a flange. Oh, interesting. Looks like someone welded that. Huh. Looks like they might have been plasma cut. So the muffler fits on there. See if I have a gasket that's appropriate for that. I ordered some gaskets. '92 gasket set, complete '92 gasket set. There's various sellers on eBay. Here we go. That be it. This gasket's probably for the exhaust elbow, but it will work here as well. All right, I'm going to go get a couple bolts. I'll be right back. Okay. These were in my 5/16 bolt bin, but they're not SAE thread. They're metric. So I need to put them aside. When I bought these engines, as I mentioned, I bought these at the estate sale, and that I went to and purchased some other tools that I mentioned in a previous episode. So this is servicing the Maytag Multi-Motor, and this is shows a model 82 multi-motor, which is, looking at this diagram, is similar to this one, except that the cylinder is turned over. So the exhaust comes out the other side, I believe, and the spark plug is on this side. So that's one difference. All right. So I think that's the other thing I got. There's lots of information on the internet. Okay. So here is what looks like exactly like my motor. And this is a 1936 3/4 horsepower Maytag engine, bought and restored by 11-year-old Jared Hall. He's from Fraserburg, Ohio. And it's on display at the 2009 Tri-State Gas Engine Tractor Association show in Portland, Indiana. So this is a 1936 3/4 horsepower Maytag. Now, based on the serial number, I looked up the serial number on this engine, and this is a 1928. So, but it looks identical to this engine. Now, the difference is it's not identical. Let me correct that. This is a short frame, mine is a long frame. So you can tell because this frame comes out past the exhaust elbow, whereas on this picture the frame doesn't come out as far. So this is a different frame than mine. But the rest of the engine, I think, is identical or darn close. Okay, so I've got the muffler on. Let's carry it outside and run it outside so we don't smoke up the shop quite as much. All right. running pretty well. I would say it's running fine. Certainly vibrates plenty. Let's see how easy it is to start again. It is dripping a little bit of fuel here. I don't know whether that's normal, how normal that is. Maybe the gas gets a little shot. Okay, but it's certainly working. Sounds good, runs good, starts easily. I'm going to say this thing weighs, I don't know, 30, 40 pounds, 50 pounds. It's not lightweight. But it's pretty cool. And a couple of interested puppies here. This is Butchie. This is Brutus. Close this door before the dogs sneak out. Alright, that's cool. So that's my first experience with a hit or miss engine. And I've seen hit or miss engines before, like at tractor shows and stuff. I never really messed with them. I don't know whether they're all two-stroke, or some are two-stroke and some are four-stroke. I'm going to guess there's probably both. This being a two-stroke does create a lot of smoke, but it's kind of cool. I'll put the points cover back on, the flywheel, and she's done. I'm going to set it aside. I've got something else to work on next episode. So thanks for watching, and leave a comment if you have any experience with these engines. I'd be interested in hearing what your experience is. Especially I would be interested in anybody who's taken an engine like this and done something other than hooking it up to a Maytag washing machine. Hooking it up to an alternator, or I've seen them on lawnmower. I've seen somebody made lawnmower out of one, and different things, go-karts, whatever. Being fractional horsepower, 3/4 of a horsepower, there's a limit to what you can do with it, but it would be cool to do something with it. So I'm going to probably get another, or maybe modify one of these dollies to hold it better. Cover it with a sheet of plywood or something, so that I could potentially attach something else on here with it. Water pump, I don't know. Play with it. Okay. Thanks for watching. We'll see you guys next time.